Hey everyone, this is Jonathan from Chegg Tutors, and this lesson is on impulse, which is just defined as the change in momentum. We normally hear in daily life how much momentum something has, which is just defined as the mass of an object times its velocity. And remember, velocity is a vector, so it has a magnitude and direction. It could either be positive or negative. So that means momentum is also a vector. So we can simplify this to just write m times v. So impulse, being the change in momentum, would just be the mass, because we can consider the mass as not changing, times the change in velocity. So you can also derive another formula for the impulse, which comes to be that it's equal to the average force on some object over some period of time. So the derivation of this is we know that force is equal to the mass times acceleration. But what is acceleration equal to? Acceleration is equal to the change in velocity over the change in time. So we can plug this in for the acceleration, and we get force is equal to the mass times the change in velocity over the change in time. So we can solve for mass here. So we get F delta T over delta V is equal to m. And we can plug this value for the mass into our first impulse equation over here. So we get impulse equals mass times delta V, and then when we plug it in, it's equal to F delta T over delta V times delta V. These cancel, and we get left with impulse is equal to the force on some particle over a period of time. So those are the two equations that you will normally be using for finding the impulse of an object. So now let's rewrite our equation for impulse, which I'll abbreviate with I, m delta v, which is also equal to F delta t. So we can see that to result in a change of velocity or a change in momentum of some object, we have to apply some force to it. Because if I have a ball rolling at me, in order to change its momentum to result in a change of velocity, I have to push on it with a force. So one of the things that the change in momentum is going to be dependent on is the force required to change this momentum. And the other is the amount of time that it takes to occur, so how quickly this change occurs. So there are some real-life applications that take into account the impulse or the change in momentum that someone will feel. So let's write our equation, I equals F delta t, and we can see that by increasing the amount of time that a change in momentum occurs over, we can mitigate the force that that person will feel. So for example, an airbag, I'm going to draw it as a stick figure, and first we'll consider the instance when there is no airbag. So if you're in a car accident and you hit the dashboard and go back, you feel a great force because this change in momentum occurs in a very small amount of time. But when the airbag is there, it slows the process down. So the change in time that occurs to cause this change in momentum is greatly increased, which mitigates the force. It decreases the force that is required to cause this change in momentum because the time it takes is increased. So same thing with a parachutist. When you're parachuting and you go to land on the ground, if you bend your knees, you greatly decrease the force that your knees will feel, because this causes this change in momentum from going from some speed to zero speed to occur over a greater period of time, so you feel less force. So now let's do an example. A 2-kilogram ball is rolling at 4 meters per second. It bounces off a wall and ends up going 3 meters per second in the other direction. The time of the collision with the wall was 0.1 seconds. So this is before the collision with the wall. This is after. And we can find the impulse. So the question asks, what is the impulse? We can find that by first looking at our two equations. And we see that there was a change in velocity here. So we can call to the left negative. So this is a negative 4 meters per second because velocity is a vector. And this would be a positive 3 meters per second. So we're going to use this equation here to find the impulse. So the impulse is equal to mass times the change in velocity is equal to mass times final velocity minus initial velocity. And this is equal to 2 kilograms minus our final velocity is a positive 3 meters per second. Our initial velocity is a negative 4 meters per second. So this is minus a negative 4 meters per second, which is just equal to 2 kilograms times 7 meters per second, because when you minus a negative, you add it. So this is equal to 14 kilograms meter per second. And that is our impulse. So what is the average force that the wall exerted on the ball during this collision, during this change in momentum? So we also know that impulse is equal to the average force over some period of time. So we have our impulse, 14 kilograms meters per second. This is equal to the force over some period of time, which was 0.1 seconds. So then we divide by both sides by 0.1, and we get the force is equal to 140 newtons. So I hope this helped and taught you about impulse. My name is Jonathan, and I'm on Chegg Tutors.